This content is produced by Pass the CSLB B, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials, so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. Temporary power should never blend into the background of a job site. The central idea is simple, because the installation is temporary, exposed, and constantly changing. The safety controls have to remain visible and active every day. A cord that was protected yesterday may be under a rolling scaffold today. A dry receptacle may be sitting in rain tomorrow. A clear panel may become a storage spot by lunch. I treat temporary power as a moving site condition, not as a one-time setup. That is the general building contractor's lane in this lesson. I am not walking through feeder calculations or internal service wiring. I am focused on the field supervision decisions that keep the temporary system usable, accessible, and protected, while several trades work around it. A good superintendent starts by defining what is actually temporary. California's low-voltage safety rules allow temporary electrical power and lighting at 600 volts or less during construction, remodeling, maintenance, repair, or demolition. The important closeout rule is just as direct. Temporary wiring must be removed immediately when the project or the purpose for which it was installed is complete. That means temporary wiring does not earn permanent status just because it has survived the whole job. If a temporary cord, box, branch, or lighting run is no longer serving the active construction purpose, it should not be left behind as an improvised, permanent installation. I use a gatekeeper test. I ask, who installed this? What purpose does it serve? What protection applies? What can damage it? And how will it be removed? Those questions keep the general building contractor in the proper role. I do not need to perform electrical trade work to recognize a missing protective device, an illegal cord repair, a block disconnect, or an exposed energized part. Based on the published CSLB study outline, electrical work and personnel safety fall within testable material. The useful skill here is not guessing a hidden exam question. It is learning how to recognize the site conditions that require a decision before work continues. The first major decision is how workers are protected at temporary receptacles. For all 120-volt alternating current, single-phase, 15 and 20 ampere receptacle outlets on a construction site that are not part of the permanent wiring, ground fault circuit interrupter protection is required unless the employer uses the permitted assured equipment grounding conductor program alternative. A ground fault circuit interrupter watches the current leaving and returning through the circuit. When the current no longer balances because some of it has taken an unintended path, the device interrupts the circuit. On a construction site, that unintended path could involve damaged insulation, moisture, a tool body, or a person. The Assured Equipment Grounding Conductor program works differently. It is not simply a different device plugged into the same box. It is a written program that uses inspection and continuity testing to verify the equipment grounding path. The program requires a visual inspection before use each day for defects such as damaged insulation or missing grounding pins. It also requires continuity testing at intervals that do not exceed 3 months. The most common confusion is thinking both systems are always legally required on the same temporary circuit. The source material treats the Assured Equipment Grounding Conductor program as an alternative to ground fault circuit interrupter protection when the complete program requirements are met. A contractor may choose redundant protection, but the legal distinction is alternative, not automatic duplication. The practical difference is easy to remember. Ground fault protection reacts when current begins traveling where it should not. The Assured Grounding program verifies, through a documented routine, that the grounding path and connected equipment remain in acceptable condition before a fault becomes the worker's problem. The comparison on screen separates the two routes. On the ground fault side, I'm looking for device-based protection at the covered temporary receptacles. On the Assured Grounding side, I'm looking for a real written program, daily visual checks before use, and continuity testing no more than 3 months apart. A label or a binder title does not replace the actual inspections and tests. Suppose a crew says, "I checked those cords last year." That does not satisfy the stated interval for the assured grounding program. Suppose another crew says, "The tools have 3-prong plugs, so no ground fault protection is needed." That also misses the rule. The receptacle requirement and the equipment grounding condition are related, but they are not interchangeable. Extension cords are usually where temporary power stops looking orderly. They move with the work, cross paths with other trades, and pass through openings that were never designed as cord routes. California's rule is direct. Flexible cords and cables must be protected from accidental damage, including where they pass, through doorways, windows, and other pinch points. A doorway is not a neutral opening. The edge of the door and frame can press, scrape, and crush the cord jacket every time the door moves. Once the jacket is damaged, moisture and conductive surfaces have a path closer to the conductors. The field decision is not merely to tell workers to be careful. The cord route needs physical protection or a safer route. Cord repair is another place where a familiar shortcut becomes a compliance problem. Flexible cords smaller than American wire gauge number 12 cannot be spliced. A hard service cord that is American wire, gauge number 12 or physically larger, may be repaired by splicing only when the repair restores the cord's original insulation, outer sheath, usage characteristics, and dielectric qualities. Electrical tape wrapped around a damaged spot does not automatically restore those properties. Tape can hide the defect while leaving the mechanical strength and insulation performance unresolved. The correct question is not, "Can I cover the copper?" The correct question is, does this permitted repair restore the cord to the characteristics required by the rule? For a cord smaller than number 12, the splice option is not available. The cord decision table on screen keeps the choices separate. Protect every cord from crushing, abrasion, and pinch points. Do not splice a cord smaller than number 12. For number 12 or a physically larger hard service cord, accept a repair only when the complete cord characteristics are restored. A tape-only wrap is not the standard. Imagine a contractor who finds a damaged light-duty cord 10 minutes before a concrete placement. The schedule pressure is real, but it does not change the cord category. Wrapping the damage and putting the cord back under load converts a visible defect into a hidden defect. The safer field decision is to stop using that cord and provide compliant equipment rather than turn the pour into the reason for accepting an unapproved repair. Wet locations add a separate layer of protection. A 15 or 20 ampere receptacle in a wet location requires a while-in-use cover that is listed and identified as extra duty. The phrase "while in use" matters. The enclosure has to protect the receptacle, while a plug is inserted and the cord is actually feeding equipment. A basic spring-loaded flip cover can protect a receptacle when it is closed, but the protection changes when the cover is held open by a plug. An extra-duty while-in-use cover encloses the connection with the cord routed out through the designed opening. The practical effect is that the connection remains protected during active use in the wet location. I do not judge this by whether the cover looks sturdy from 6 feet away. I look for the correct listed and identified cover for the location. I also look at the box, cord entry, and condition of the enclosure. A proper cover does not make a cracked box or damaged cord acceptable. Cord and plug connected equipment also needs a grounding decision. Equipment with exposed non-current carrying metal parts must be grounded, unless it is protected by an approved system of double insulation and is distinctively marked. The key is the marking. A plastic housing or a 2-prong plug by itself is not my proof that the tool qualifies for the exception. This is a useful distinction during a site walk. For a grounded tool, I check the plug and cord for the grounding path and obvious damage. For a double-insulated tool, I look for the manufacturer's distinctive marking. I do not create a third category called probably fine. Temporary power often begins at a pole or portable generator, and both have details that are easy to oversimplify. A temporary wood power pole must be at least 6 by 6 inches when square, or 5 inches in diameter when round. It must be at least 20 feet long and embedded 4 feet into the ground. Those dimensions are not a substitute for evaluating the actual installation, soil, loading, bracing, utility requirements, or electrical work. They are the minimum temporary pole dimensions identified in the source material. The general building contractor's field role is to recognize when the basic support does not even meet that starting point, and to coordinate correction by the responsible trade. Portable generators have a narrow frame grounding exception. The generator frame does not require a separate grounding electrode when the generator supplies only equipment mounted on the generator and cord and plug connected equipment through receptacles bonded to the frame. The condition matters more than the slogan. Portable generators never need grounding is too broad. The exception depends on what the generator supplies and how the receptacles are bonded. When the setup falls outside those conditions, I do not extend the exception by habit. I verify the applicable requirements for the actual configuration. Now move from the source of power to the space around the equipment. Energized parts operating at 50 volts or more must be guarded against accidental contact. The source material identifies guarding through approved cabinets, dedicated rooms or vaults accessible to qualified persons, or elevation of at least 8 feet above the working surface. The 50-volt number is a trigger for guarding. It is not permission to treat every lower voltage condition as harmless. Damaged tools and wet temporary circuits still require the protections already discussed. The threshold tells me when the specific guarding rule for energized parts applies. Working space around electrical equipment has its own rule. It cannot be used for storage. I do not need a tape measure from this research report to recognize the basic violation. A ladder, stack of drywall, pipe bundle, tool cart, or scrap pile occupying the required working space creates an access problem and can interfere with operation or emergency de-energization. This is one of the easiest hazards to create because the panel space often looks like unused wall area. It is not unused. It is reserved work access. I treat the space around electrical equipment the same way I treat an exit path. Available means available now, not after somebody moves 3 things. Disconnecting means also need clear identification and control. Each disconnect must be legibly marked to indicate its purpose, and it must be capable of being locked in the open position. An unlabeled breaker or switch forces a worker to guess what will be de-energized. A disconnect that cannot be secured open undermines the next safety step. That next step is hazardous energy control. Before work on a de-energized electrical system, the authorized person secures the disconnecting means in the open position with a lockable device and applies the required accident prevention tag. The tag is not a generic decoration. The source material requires the reason for the tag, the identity of the authorized person who applied it, and the date it was applied. A tag that only says danger or do not operate does not carry the full required information. Lockout is the primary physical control when the disconnect can accept a lock. The tag communicates who applied the control, why it is there, and when it was placed. I remember the 3 tag facts as a reason, person, date. That short sequence keeps the information practical without turning Lockout into paperwork theater. The site safety program needs the same level of specificity. Under the Injury and Illness Prevention Program framework, the employer's written code of safe practices must relate to the actual operations and hazards of the site. A generic manual that never addresses the work being performed is not made effective by sitting in the trailer. For temporary power, site-specific practice may address who inspects cords, how damaged equipment is removed from use, which protection method is being used for temporary receptacles, how wet location boxes are maintained, who controls lockout, and how clear electrical workspaces are enforced. I am not inventing a universal form. I am showing the kind of operational connection the written practice must have to the real job. I want to put the whole field walk into one sequence. I start at the source and identify whether I am looking at a temporary service, a portable generator, or another approved supply. I check the support and the conditions that apply to that source. Then I move to the temporary receptacles. For the covered 120-volt, single-phase, 15 and 20 ampere outlets that are not part of permanent wiring, I verify ground fault protection or a fully implemented assured equipment grounding conductor program. If the assured program is used, I look for the written program, daily visual inspections before use, and continuity testing within the 3-month interval. Next, I follow the cords, not just the boxes. I look at plug-ins, grounding pins, jackets, splices, doorways, windows, traffic paths, water, and places where a cord can be crushed. A cord can look fine at the receptacle and be damaged 30 feet away. At the tool, I verify grounding or the distinctive double insulation marking. At wet location receptacles, I verify the listed extra duty while in use cover. At panels and disconnects, I verify guarding, clear working space, legible identification, and lockability in the open position. The checklist on screen follows that same walk. Source, receptacle protection, program records, cords, wet location covers, tools, panels, disconnects, and closeout. It is not a substitute for the electrical trade or the site safety program. It is a supervision framework for catching visible conditions before they become accepted habits. Finally, I ask what happens at closeout. Temporary wiring must be removed immediately when the project or its temporary purpose is complete. Closeout is part of the original plan, not an afterthought. If nobody owns removal, temporary installations have a way of becoming permanent by neglect. The memory connection I want you to keep is protect, inspect, isolate, and remove. Protect receptacles, cords, wet connections, and energize parts. Inspect the grounding program, tools, covers, labels, and workspaces. Isolate hazardous energy with a lock and a complete tag. Remove temporary wiring when its purpose ends. That sequence keeps the lesson in the general building contractor's field supervision lane. I'm not asking you to design the electrical system. I'm asking you to recognize whether the temporary system is being controlled as the site changes. There is an audio practice quiz for this specific episode, and I built it around these temporary power decisions. It is audio-based, so the questions are read aloud and you answer by tapping, which works well when you are studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it, it will take you straight there. Comment below with any questions about what I covered, and subscribe so I can help you stay on track through every episode until you get your license. I know you are fitting this study time around real work and real responsibilities, and I want each lesson to move you one clear step closer.